Here we're looking at the number of malaria cases in children under 5 years of age in Ghana, modeled by the following quadratic function. So what's the first thing we notice? Well, C is 583, 452. That means initially there were 583,452 cases. So this is years after 1998. So this was 1998. This was the number of cases. Okay, well the value, so that if I were to begin sketching this, let's just say that's 583, 452. Now the initial rate of change is 658,186, and this is, well, what are the units for this? The units for this are change in output over change in input. So our output measures the number of cases. I guess we'll call it maybe just cases. And our input is time, so that's measuring years. So C is cases, T is years. So our units would be cases per year. So initially the number of cases is on the rise. But we notice that the A value is negative. So really the meaningful value is twice that. And if we look in a table, we see that as the years pass, the number of cases is increasing until, looks like after, so 1998 plus 2, this is the year 2000. From 2000 to 2001, it looks like the number of cases drops. So here are the rates of change, and we notice that twice A is negative 280, 562. So that means that the number of additional cases each year is dropping by 280,652 cases per year. So the number of additional cases is dropping by that much. So that means the change in the number of cases is getting less severe. So the rate of change is slowing down until it kind of flatlines, and then the number of cases begins to drop, kind of like this, as time passes by. And so hence we notice that these guys begin to go down. Now of course in this table it appears that they go negative, but that may be based on the fact that our model isn't that valid for many more years after that, because according to this, these negative slopes get steeper and steeper. So there are interpretations for A, B, and C, and they allow us to also create this sketch.